The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
15, I guess we should get this show on the road. So, this is a talk about bulletproof bash scripting. So, let's start with a little history of bash. So bash was part of the GNU project, written by Brian Fox. Now, Richard Stallman of infamy, or fame, or whatever, of the GNU project, thought that it was really, really important to have a shell that was fully compatible with the Bourne shell. Of course, the vast majority of scripts in the Unix world are written in the Bourne shell at that time. So they actually funded, out of their own foundation's coffers, Brian Fox. They employed him and funded him to work on this project. And it was first released in 1989. And of course, it was a true superset of the Bourne shell. So that's our history lesson. Now, I'm talking about bulletproof, so-called bash scripting. So what does bulletproof mean? Well, I pulled some words out of a dictionary and kind of threw them up here, and I thought they looked pretty good. Robust, predictable, repeatable, accurate, exacting. And we'll kind of talk about how each of these applies along the way. But, you know, a lot of people, they have this notion about bash scripts that it's hit or miss, you know. It either works great or it fails miserably and I don't know why it failed. Or it fails miserably and it took me a week to figure out why it failed. Or the user says it fails, but it always works for me. See, these are things that violate this whole idea of bulletproof. If it's predictable, if it's repeatable, it's going to work the same for you. It's going to work the same for your user. It's going to work the same night, noon, morning, whenever. So let's keep going. Come on. You can do it. Whoops, missed a slide. What bulletproof is not? Bulletproof is not secure. They're not the same thing. They're two different worlds, really. So I'm going to just say never make a setuid root bash script. Just don't do it. Just resist the temptation. It's bad. There are too many attack vectors. Clearly there's path, there's LD library path, there's the input field separator, IFS, there's temp file hijacking, and that's just a start. So if I'm on a box and I'm a regular user and I see a setuid bash script, pretty good chance I can get root on that box. So avoid that. That's not what we're here to talk about. We're not here to talk about securing these things. We're talking about making them repeatable, making them robust. So we're going to start with path and UMask. Now, everybody knows about path and UMask, but I'm going to say it just to be complete. You should always set both, in my opinion, and a shorter path is usually better. I see people who make paths 10 miles long, but you know what? I think you need 4. Maybe you need user local bin 2, maybe 5, but usually 4. User bin, user sbin, and sbin. And UMask is a lot less work than doing chmod on everything after the fact. So UMask sets a mask against the default permission. Usually when you create a file, it has a default permission of 666, read write, and then the mask is subtracted from it. So if you subtract 22 from that 666, you get 644, or read write, read for group, read for other. So UMask it's a lot easier than trying to remember to go back and chmod all the files after the fact. Set-xv. This is where it starts. This is where it starts to get good, in my opinion. Set-xv, a lot of people, they play with it, they turn it on, they think, oh my gosh, what is all this gobbledygook? I can't read this. They turn it off, they walk away, they never look back. That's okay, I can relate to that. I was that guy at one point. But I finally learned to love set-xv. What it does is it prints each line as the bash shell reads it to the standard error. Then, on the next line, it prints a plus sign, and it shows you the final version of that line after variable substitution, after path name expansion, after quoting resolution, word splitting. All of that happens, and then the shell will show you what it's finally going to do. So you get to see kind of the before and after, and that's really helpful in understanding what that shell's doing. Now finally, pipes, shell functions, and redirections, they can be a little non-intuitive, but we're going to have some of those in the examples. So I'm going to point that out to you, and I'm going to say, hey, look, remember when I said non-intuitive? So we'll see that in a minute. Now, exec to greater than log file. This opens a log file for append, and it redirects the standard error output to this log file. This is going to capture the errors from our programs and the output of the set-xv. All of that's going to go into a file so that we can always have a sort of record after the fact of what the script did, and we can understand it. We can go back and see at each step in the script, what did it do? My typical usage, I use exec 3 greater amper 2, amper $me.log, where me is a variable I've set to the name of my script, and then 2 greater than amper 1. So what this does, this opens file handle 3 as a dupe of the standard error. So I've still got the standard error, even though I'm going to put the standard error output to this file. And it also sends the standard output to this file. So this is going to capture pretty much everything that's going to come out of this script into this file. And if I still want to send an error message to my user, I still have a dupe of standard error on the third file handle that I can do that with. Set-E. Now this is what makes it possible, in my opinion, to have bulletproof bash scripts. Set-E is error checking on steroids. It's error checking built in. It's the shell doing all the error checking for you. What it does is the shell checks the return code of every simple command after it runs it. And if any of these simple commands returns a non-zero error code, the shell exits. So it stops. A lot of times in our bash scripts, the shell goes right along, does whatever we asked it to. It has an error. It doesn't notice the error. I mean, why should it? And it goes right on to the next thing, and it keeps going. And only after the fact, when your shell said it did what you wanted it to do you realize that it missed something along the way. Set-E prevents that from happening. Set-E throws the brakes on the instant you encounter a problem. And this works for the built-ins too, like CD, change directory. Now, sometimes you want to ignore an error. You're really like, I just don't care. You want to make the directory foo. It might already exist. You don't care. The easy way to get set-E to ignore that is to add or and a colon. Colon is the no-op in the shell. Colon does nothing. So you say, make dir foo, and if that fails, do nothing. See, that takes this simple command, make dir foo, and makes it into a complex command. And set-E doesn't check on complex commands. It expects you know what you're doing, right? You made it complex. You must want to handle that error condition yourself. Come on, next. Okay, ad hoc error checks. This is what people normally do, right? People will go into their bash scripts and they will put an if-then around every line, practically, to say, if it didn't do what I wanted it to do, throw some big error message to a log, yell bloody murder, set the fire alarm, do something. The problem with ad hoc error checks, well, there are 4 problems. There are a lot more than these, but these are the ones I threw on the slide. They take time and effort to write, obviously, and they seldom include everything you want to know. How often do you actually see error messages that say what line it failed on? People don't usually do that. It's too much work. They're only added to the places you think are going to fail, which is not usually the places where it does fail, because it's usually the surprises that get you, not what you were expecting to happen. And they can even introduce more bugs. I can't tell you the number of times I've had to debug somebody's error code, somebody's debugging code, and that's just like, okay. Trap, bang, exit. So trap is kind of it's sort of the unexplored wilderness of the shell for most people. Most people don't use traps. Traps let you catch signals. SIGINT, SIGHUP, all of that. Everything that your normal daemon can get and react to, well, your shell script can get and react to too. But it can also do other things. Trap can handle things like the exit condition. So my usual formula is to put a trap on exit. And I call it bang, just for fun. Because, when a machine dies, you want it to go bang. You want to know it happened. You want the blue smoke to rise. You want to know some sort of indication, oh, that one's bad. So I call it bang. So trap, bang, exit here. It runs just before bash exits. And bang, in my typical usage, my typical recipes, is a shell function. And I use it to alert me to look at the log file. So all the really good stuff is in the log file. But if it all worked just fine, then I don't need to look at the log file. The log file is going to be full of stuff that was just fine, and I don't need to go look at it. So I want the bang to tell me, hey, look at the log file. Now, to disable a trap, you just trap again, and this time you use dash as the argument. Set-u, this is a lot like set-e, but it works for variables. So set-u treats unset variables as fatal errors. And this is an alternative to supplying defaults for every one of your variables. A lot of times our bash programs fail because one of the variables wasn't set. You end up with a command line that would have done something interesting if that one variable had been set to the right path, but it was empty, and so the whole line failed. This will catch that before running that command. Now this also affects $1 and $2 and whatnot. So if you're going to use positional parameters and you want one of the positional parameters to be optional, you say you want it to be possible to give $2, but not always are you going to give $2 to a given shell function, then you need to use a default there. So like $curly brace 2 : close curly. flock. Now, in the little snippet that I put into the book, which amusingly got mashed up with my other talk here about regular expressions, in the little snippet, I described the traditional cron problem. We all write, well, sysadmins and lots of other people write cron jobs. And we want our cron jobs to run once a day, right? We put it in the cron.daily, and we think that's good enough. Surely, right? It's cron.daily. It's going to run once a day. And then a month or two later, you log into your system. It's completely crawling. It's at a standstill. And you're like, what's going on? And you look at the process table, and you see 30 of your cron jobs sitting there chewing up resources, memory, CPU. And they're all running, and it was supposed to run once a day, and it was supposed to finish in a day, and it was supposed to exit. And the next day, another one was supposed to run. But what happened? It took longer than a day. The next one started before the last one finished. They started competing with each other for resources or locks, or there was some sort of race condition. And next thing you know, you've got 100 of them, and the machine can't do anything at all. flock solves this. flock is exclusive advisory locks. So flock is both a system call and it's a little utility. The little utility that we call from our shell scripts just calls the system call. Now these are, let me explain those two words, exclusive and advisory. Exclusive means only one thing can have the lock at a given time. Now this is as opposed to a shared lock, or read-write locks, where you can have multiple reads and only one write. So exclusive is our typical write lock. Advisory, that's pretty important. Advisory means people can ignore it. An advisory lock only works when everybody's looking at the same lock. It means it only works when the programs cooperate to say, okay, yes, I am going to treat that lock to mean don't do something or do something, and so forth. If you have two different locks and the programs aren't using the same one, well, then they're not agreeing, they're not communicating. So flock is exclusive advisory locks. And I usually use the -in switch for non-blocking. If I don't get the lock, I want my program to exit immediately. And I use it on a file handle opened by bash with that exec syntax. And this is handy because when I open it on a file handle that my script already has open, when the script exits, the file is closed, the file handle is closed. And when the file handle is closed, the lock goes away. So I never have to worry about unlocking. That all happens automatically when the script exits. All right, I think we're just about ready for an example.
Quick question. So you
Yeah.
want like standard in, standard out, proc self, is that what you're usually looking for?
Standard in or, well, standard out would work.
Standard in, standard out.
So is this my script? Yes, okay. Here, okay, so here I just opened one, okay? I used 4.
Oh, so you open a new one.
So you could use an existing one or you can open a new one. And everybody, just to be sure about this syntax, exec is a way you can open a file inside the shell script, and it behaves the same as if you had typed on the command line when you ran the shell script an open bracket into some other file. But you can assign numbers. So in this case, I use the number 4. But let's kind of talk about this real quick. So basically, everything in this script is something we've already just talked about. We have our path and our UMask at the top. We have our exec line to capture the standard error output into a log. We have our set-xveu, so all 4 of them right there in a row, doing all the good things that we want them to do. And this is just very typical for me to throw in date and host name there. I use that because when I look back at this file, I can see when the script started and what box it was running on, and that's handy. And because we're capturing the standard output as well as the standard error into this log, just a simple date command is its output is going to go right to that log file. Next we have good old bang and trap bang for exit. Now here's just a directory. I made this up, cd opt query. Here's our flock line. Here I'm sourcing a file to get some configuration variables. This db log keep and db log pattern are supposed to come from this config file. And then I've got your very traditional find pipe to xargs rm. So this is something any sysadmin might write. I want to find files that are older than some number of days that match some regular expression pattern, and I want to remove them. Finally, I've got trap -exit. So if I get to this point, my script has succeeded. And I'm going to undo my trap so that when the script exits, it'll be silent instead of going, bang, it failed. And then I have an exit 0. So this is a very simple script. Now let's see what happens as I step through. It failed. Well, of course, this is a contrived example, so you knew it was going to fail, right? This is what I want to talk about. I want to talk about how to keep them from failing or how to figure out why they failed. So if I go back and look at the log file that I captured by virtue of set-xv, I can see the date, I can see the host name. This was a virtual box, so it just had the default host name Ubuntu. I can see, so each of these are the lines as the program read them. This is the xv output. So host name, that's what it read, plus host name, that's what it ran. Bang, this is what it read. Now, when it defines a shell function, it doesn't actually echo that back out. Trap bang exit, read it, ran it. cd/opt query, read that, ran that, and here's our first error, okay? I didn't make opt query intentionally. I wanted it to fail here so I could show you. So this is what that output looks like. It tells me the name of the program, tells me what line it failed, tells me what it was doing, cd/opt/query, and tells me the error message that happened, no such file or directory. So that's a pretty good error message in my opinion. That tells you a lot right there. You know just what went wrong. And of course the bang, because the set-e caused the script to exit at this point, because this returned a non-zero return, and it echoed failed, and that of course got my attention to go look at the log file. Okay, So I'm going to make dir opt query because I really want my program to finish. The next line up here, I do a no op and I redirect it into RM logs, and that's my typical way to truncate a log file. You could RM it, yeah?
You should be able to just do a redirect to it without the no-op, right?
I'm old-fashioned, man. That's muscle memory there.
I was just wondering if there was a reason you were doing that.
You could do it without the no op, but you know, I explicitly put a no op in there. What can I say?
Nothing wrong with being explicit.
That probably goes way back if I had to guess. Anyway, so then I run it again, and of course it fails again because, you know, this is a contrived example. So what happened this time? So here's the same, here's our next set of output, and you can see we got past the cd opt query this time just fine. We even made our lock file just fine. What happened here? It went to source, this opt-etsy rmlogs.conf, and that file didn't exist. And again, it tells us the name of the program, the line on which it failed, and this opt-etsy rmlogs.conf, no such file or directory. So we know just where to look, okay? So I'm going to go and I'm going to empty my log again, and then I put some variables into that file, and I cat it out here just to show, yes, I'm a good boy, I put variables in my file. I say 7 days, and there's a little regular expression to match dump and a few numbers, 3 numbers afterwards. And then I run it, and it says failed 3 times. Bang, bang, bang. What is that all about? Okay. Let's see what happened here. Okay. So here, we're a little farther down in the log file, and it went to source our rmlogs.conf, and that worked. It got the 2 variables. We can see those here. They're preceded by 2 pluses this time. And then we run our find command. But sure enough, we see unbound variable, and we see it twice. This is the set-u in action. And the reason we're seeing this is because I misspelled the variable names. You know, I put db log keep, and it's dbg log keep. So this is you can actually make mistakes like this, and here it is telling me, look, you made a mistake, this is what it is. And the reason we see failed 3 times is because this is a pipe. So the way the shell sets up this pipe, it essentially has a context for each section of this pipeline. And in each one of these contexts, the first being the find part, there was a failure. There was a failure because that variable was unset. In the egrep part, there was a failure because that variable was unset. And in the xargs rm part, there was a failure because rm had no arguments. And we can even see that down here. Here we actually see the capture of RM's error message. RM, missing operand. Try rm -- help for more information. Who says Unix isn't friendly? Okay. So I fixed the problem, right? I went in, I edited the config file, I put the little extra letters in there, I run it one more time, and sure enough, it works just fine. I'm sorry, I keep swinging my hand and bumping into the mic, so forgive me. It works just fine. So let's see what the log file looks like when it works just fine. When it works just fine, we see the xargs, the find, and the egrep. Now, you remember when I said it was a little non-intuitive, the way the -xv output looks when we have a pipeline? Well, here's an example, right? You would expect the find to be first, the egrep to be in the middle, and the xargs to be at the end in this output, but that's not what it looks like. And in truth, it doesn't matter. So long as the standard ins and the standard outs are connected correctly by the shell, it could really execute them in any order. And here we see it says removed dump.149, 150, 148, 147, 146, 145. And the reason it says removed is because I put the -v switch on RM. Now, how many people have seen all these verbose switches on things like move and copy and RM, and you think, I'd never use that. I never want to see every file it operated upon. It's going to fill up my screen. Well, finally, you've got an excuse to use those verbose switches. You can actually have your log tell you which files it operated on, and there you've got proof. These are the files it actually operated on. Now, one thing we don't actually know in looking at this output is we don't know what files find saw. We only know what files got removed. And so those are files that find saw that match the egrep regular expression and that then were operated upon by RM. So let's see if we can go a little farther and do something different. What I'm doing here, I'm adding one function. I call it cat2. And you're not going to find this in any man page. This is something I just do because I like it. It's a little Perl one-liner that says print to standard error. And because it's Perl, you can say things in a very short way. So what this does is it takes every line that it reads and it writes one copy to the standard output and one copy to the standard error. Now, why would you want to do that? Well, the reason you'd want to do something like that is you could insert this into the pipeline. The copy of the line that gets written to standard output is going to continue down the pipeline. And the copy that gets written to standard error is going to show up in our nice little log file here, captured for us to inspect later. So this is what happened when I ran it with the cat2. I can see, and I also recreated all of those dummy files. Yeah?
I'm sorry, your Perl script does what again? It's in standard out to standard error?
It reads a line, and then it writes that line to standard output, and then it also writes the line to standard. Oh, I'm supposed to reiterate the question. That's what that means. All right. Let me reiterate your question. You asked, what does the Perl script do? So the Perl script reads a line, and then it writes that line to the standard output, and then it writes it again to the standard error.
Would that be different than using T to write to file?
Would it be different than using T? It would be conceptually the same if T would write to the standard error. Now, you actually can use T to write to the standard error if you write to /dev/standard error, which is actually a symlink on Linux boxes to proc self fd2. And you need to append, because if you don't append, it's going to truncate your log file. So I've been down this path, can you tell? In my final analysis, after having my log files truncated through missing that part, I find that my little cat2 is a little more simple and easy and doesn't get me into trouble. So here we can see that the cat2 showed us what find output. And then we can see what egrep and rm did. And we can see that there were actually some other files in that output that maybe we wanted to delete, but we didn't delete. Those are the ones named diff.149 and diff.145 and so forth. So sometimes it's useful to see not only what you did, but what you didn't do. So we didn't delete those files. And that's easy to do with this sort of capturing everything kind of approach. Okay. So let me talk about expression in single brackets versus expression in double brackets. How many people, just show of hands, use double square brackets? Right, we've got 3, 4, 5. Hey, all right, that's good. How many people use just single square brackets? Okay, as many, and some people who use both. Okay, I see that. So I'm going to tell you, the double square brackets are newer. They are a bash innovation. The single square brackets are actually backwards compatible all the way to the original Bourne shell. So bash has to be a superset of Bourne. So it has to do everything the Bourne shell would do. And the Bourne shell would do these single bracket expressions. But Mr. Fox said we can do better. We can make it better. And he came up with these double square bracket expressions. And there's two differences, two very important differences. The single bracketed version does word splitting and it does path expansion. And I've got some examples to show exactly what that looks like coming up. And the double square bracketed expressions does not do word splitting or path expansion. And frankly, I think that many of the errors in our bash script come from accidental word splitting and path name expansion. So let's see what some of this looks like. Now this is clearly a very contrived example. I've got a variable foo, which is 1, and a variable bar, which is 1 space 2. And if I ask bash to compare foo and bar in a single bracketed expression, I get the error. How many times have we all seen this? Bash, open square bracket, too many arguments. And what do we traditionally do about this problem? We wrap it in quotes. Everybody does that. But that's something that you can forget to do pretty easily. Or you can put it in single quotes and then it doesn't do at all what you thought it was going to do, what you meant for it to do. So yes, you can put it in double quotes and it does work. But you can also use the double bracketed version of this expression, and it works correctly because there's no word splitting going on. That space in the bar doesn't matter because word splitting doesn't happen in the double bracketed comparison. So here I'm showing, this time with the -xv output, I'm showing path name expansion. So I do an ls, and you can see that I've got a directory with half a dozen files. And if I say in a single square bracketed expression, -f dump.151. Yeah, question?
Yeah, I'm sorry. I wrote a bash script where, unfortunately, on some of my files that I've downloaded or maybe transferred from a Windows machine that had file spaces in the file names.
Mm-hmm.
So I could use maybe the double brackets
You could.
to eliminate problems.
Well, I'm going to show you an alternative in just a second, which I think is even better. I frankly am of the opinion that you don't want to do either one of these. But I want to show it just to make clear what the difference is. So if we do our single bracketed test on a single file, it works just fine. But if we do our single bracketed test on a file name with a wildcard in it, we again get the infamous too many arguments. And you can see in the -xv output that what the shell actually tried to do was open square bracket -f and then half a dozen files. And that is indeed too many arguments. That's not going to work. If we do it in the double square bracketed expression, the test of a single file works correctly. But if we do it with the wildcard, it doesn't work correctly because there's no path name expansion. What this is actually asking is, does there exist a file that is literally named dump.*? Not, is there a set of files that match dump.something? So this is probably not what you want if you want to work with wildcards. But now let me show you what I traditionally think is a better approach to this problem. Now, you saw me use xargs in my example program, and that comes from a long history of being abused by wildcards. Because you see, wildcards, the shell is really happy to just expand that and expand that and expand that. But on our Linux and Unix environments, any program can only take so many arguments. So if you've got a directory with several thousand files, and we've all done it, right? Directory with several thousand files, and you try an rm star, you're going to get an error because there are too many arguments for rm. So xargs is our traditional answer for that. If you can get those files in a list, say with find, and pipe it into xargs rm, it works just fine. But in the same way, you don't really have to use wildcards to do something like test for the existence of multiple files. You can use something like ls and pipe it to egrep. And that's a very similar thing to what I did in the first script. So here I am, I say ls pipe to egrep /dump \dot. Now that's a regular expression that means the same thing as dump.star in bash. Okay? So these two are equivalent. I say ls pipe to egrep and that regular expression and echo true. And the ls works, it lists the files. Pipes to egrep, we see that egrep does indeed match some things, and we get our echo true. And if we don't actually want to see what egrep saw, if we just want to take its word for it, you can use the -q switch to make egrep quiet. So this ls pipe egrep -q dump dot and echo true is the way I would do this in my scripts, and the way I would suggest you do it in your scripts, because this is going to solve several problems, including your problem with spaces. All right. Now, word splitting again. Word splitting is is one of the biggest problems people encounter in bash shell scripts. Word splitting always happens when you don't want it to happen, and it doesn't always happen when you do want it to happen. So here's a little shell function I threw together to list out the arguments. I call it inargs. And basically, it's going to put a number beside each argument that I gave to this shell function. So if I say inargs ABC, I see that there were 3 arguments, 1, 2, and 3, named A, B, and C. But if I quote, and I make that first argument A space B, I've given this shell function 2 arguments. But what do I get on my output? I still get 1, 2, 3. And that's because word splitting occurred. If I do it on the other side and I put B space C in quotes, I again get word splitting. It always looks like 3 arguments. If I give it a single argument, A space B space C, word splitting again occurs, and I get 3 arguments. Now, what can I do to make this better? What can I do to fix this? Stop using $. $$ is just this side of evil. Now, what is good? Double quote $@ double quote. How many people use that? Double quote $@ double quote. Okay, good. We've got some. It's great. You should use it everywhere you'd be tempted to use $. Use that. What that does, the shell says, I will preserve the quoting and not do word splitting inside when I'm replacing double quote $& double quote. Now, I've got another slide of this where I turned on the XV output so you could see what this looks like. So here is my bad version again at the top that just uses $. And you can see that when I hand it A space B as a single argument and it runs, you can see what, sorry, I did it again. You can see what actually happens is the shell runs that little Perl snippet with A, B, and C. But if I do it with my $& in double quotes, what the shell actually runs is this Perl snippet and then preserving the quotes, single quote A space B, single quote C, and we get our desired output, which is 2 arguments, one of them containing the space. Okay, wow, we whipped through this, or did we? Maybe it just felt fast to me. I think this is my next to last slide, which I threw in because I wanted some filler in case I went fast instead of long. So what is this? This is some little improvements. When I wrote that first script to show you guys, I basically based it on a real script I have, but I stripped out some of the things which look kind of like line noise or gobbledygook. And here I'm going to show you some of those back from the original script. What I usually do with my bang, this is a better bang, is I actually test $?. Captures the return code of the last thing to run. And I test it. And if it was equal to 0, I just return inside my little bang. And this time I call it end instead of bang because if the script exits correctly and successfully, if the last thing to run gave a 0 return code, then I don't need to say failed. It didn't actually fail. So by testing $? To see if it was 0, I can leave this trap in place for the whole script. I don't have to disable the trap. Basically, the trap is smarter. It knows whether or not the script really failed or whether it succeeded. Better bang. Okay, better base name. I don't know how many people actually use Bash's built-in variable editing replacements. But we see things like base name $0, and that's really easy, right? But you can also do that by operating directly upon $0 with a replacement. So this double hash sign says to take this pattern, the longest version of this pattern, and to replace it, or to chop it off. So basically I'm saying everything up to the last slash in the line, throw it away. And that's just what base name does. So this is a way to do base name entirely inside of bash. And once you start doing it, you'll get addicted to it, and you'll be doing all of your replacements inside and a lot less calls to sed, awk, Perl, base name, what have you. And then a better top directory. So in my script before, I had hard-coded things like opt, /opt/bin, /opt/query, /opt/etc. When I write real scripts, I almost never hard-code those things. Because on some boxes, I might put a script under op. On other boxes, I might put it under user local. On still other boxes, like at work, it'll be /securework/bin or something. So these things can live in multiple places. And the fact is, it's really easy to figure out where the script lives. Because $0 contains the path to the script. Now, it's either the full path to the script, which that's going to be the case if you run the script and the shell has to go search the path to find it and run it for you, then that's when you're going to get the full path to the script in $0. Or it's going to be a relative path to the script. And that's what happens when you say ./bin/foobar. So what I have here is a little test. And this is again using some of Bash's built-in variable manipulations. So what I'm saying here is this actually evaluates to the first character of $0. So I'm asking, is the first character of $0 a slash? If the first character of $0 is a slash, well then I know I've got the full path in $0. So I go ahead and set top to be that full path. If it doesn't start with a slash, I know I've got a relative path. So I set top to be the value of PWD, or the current working directory, followed by $0. And then, again, using some of that bash built-in variable replacement, I just strip off the /bin/whatever part of that directory. So, in my earlier case where my script was called rmlogs, if I called it /opt/bin/rmlogs, then top would get set initially to opt bin rmlogs, and then it would strip off the bin rmlogs part, and top would be set to opt. And then I could use that variable top and reference all of my subsequent files, like my config files and my log file, relative to that top directory. And that could be opt or user local or, well, anything. All right, so that was the better top. Okay, not so many questions.
Start with an order.
Hmm?
Is that an order? Is that height there?
This is double square brackets.
Oh, okay.
Yeah, so this is a test. It's testing if the first character of $0 is a slash. And then I'm using and for the true part and or for the false part. Yes?
What is it that the standard base name command isn't doing that yours is?
The question, what does base name do that this one doesn't? They're doing exactly the same thing. Now, there is something you can do with base name. You can actually also have base name strip off an extension. But if you're putting extensions on your scripts, you got to just take the leap into the Unix world, because, oh, I'm sorry, I hope I didn't offend anybody. that .bat stuff, that's something that those Windows people did. We don't need that. In Unix and Linux, everything can be an executable. It can be a Ruby script, a Python script. It can be a C program. It can be, you can even make your Unix boxes, well, you can do a lot of things with them. So having extensions to try and give some sort of reminder that this is a shell script versus a regular program, that usually just gets in the way. So it doesn't do that. But you could make it do that if you wanted to make it a little longer. All right, so do I have anything else? I don't think I do. I lost my connection while we were talking. Yes, and if you want the slides, they're available at dancancode.com, which is my failed blog, but it's still where I put my slides. And I put this XKCD up here because this makes me laugh, this part. His blog has 4 posts, all apologies for not posting more. How true is that? How many blogs out there are just, you know, really, I'm going to start writing more, I'm going to start writing more. Well, I don't actually say that on my blog, but I don't write a lot on it, so it doesn't say much in the first place. Anyway, I love XKCD. You know, Randall's great. I think he speaks to our generation. But that's the end of my talk. Any more questions? Yeah, question.
Is there a difference between bin sh and bin bash? Because they're often just symbols, but I don't know that they can still do something different.
That's a good question. Is there a difference between bin sh and bin bash? When they're symlinks, they are in fact the same program, but the question would then be, does bash do any POSIX emulation when it notices it's being run as bin sh instead of bin bash? And honestly, I'm not sure. I would have to look at the man page for that.
My follow-up question would be, what do you use like a hash bang, bin?
Bash. I always say bash. I don't want there to be any doubt. I mean, bash really has been around, you know, 20 plus years, right? So, and it's on all distributions, on all Linux distributions, and even on pretty much all Unix distributions that are what's left of them.
You will encounter places that don't have bash installed if you venture outside the Linux world.
Well, of course you will. But the first thing you're going to do is install it, for crying out loud. I mean, come on. You know, that takes me way back. I remember the first Unix box I worked on was SunOS 4. It ran on, actually on the Motorola chip. This was before Sun introduced the Spark chip. They were still selling Motorola chips. And this was multi-user Unix. You know, most people these days, they have Linuxes, they have BSDs, whatnot, and everybody is basically on a single user machine. There's so very few multi-user Unixes in the world anymore. They still can do multi-user, mind you, but nobody uses them for that purpose. So that original sense of community you had, where you had a system administrator who was the only one who had the root password, and you could go pester him for questions like, what does this do? What does that do? That sort of sense of community is actually, it's been lost. And that's kind of a sad thing. But in its place, we have this. We have conferences where we can all get together and have some community again. So that's nice. But I do remember the days when you would run talk on your multi-user Unix box, and you would talk to the sysadmin, and he would talk back, and you could actually get to watch him typo as he, you know, I remember telling somebody, I speak typo. You really don't have to backspace over a whole line just to fix that one letter. But, you know, those were the days. Those were the days. All right, so that's all I've got. Oh, another question.
Just to answer his question, so when you set it to sh, even if it's sibling to bash, it will force things that are bashes and specific to the extensions to bash will stop working. I ran into this when magically, I set it up when I was first learning it.
Yeah.
I went, why does this not work? And I had to dive into the world of the difference between the extensions to sh that are in bash and sh.
Yeah.
So that's what it seems to do.
Yeah, okay, so we do get POSIX. Repeat the question, or no time left?
Either one. Yes, there are other programs in Unix that do that too.
Mm-hmm. Oh, yes.
And secondly, I just recently came into an AIX box, a fresh install of AIX,
Uh-huh.
and it had an include bash or, a dozen of our favorite toolkits.
Oh, yes. Oh, yes. And now you get to rush out and install all those, because what is a Unix world without the GNU tools anymore? Really, we don't want to be there. And that was that battle was won a long time ago. All right, any more questions? Yeah, question.
What's a comparison of bash and corn shell?
Corn shell. Wow. Okay, so yes, corn shell still exists in the world. I'm sorry. I've had to use it before. But we could just stop there and say, use bash. Bash is good. Corn shell, it was cool for the time. Corn shell had a built-in menu system, which was kind of cool. you could actually write your scripts to prompt the user with a fairly simplistic menu interface. And that was about the best thing I could say about it. Okay. Otherwise, it was largely Bourne compatible, but it was not open source. It was part of Sys5, I believe, Unix, and it's never become very mainstream outside of System 5, and it's largely been replaced by Bash in the rest of the world. Any more questions? Okay, thank you, everybody. Thank you for coming.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You'll have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
Cloud Stack Management Server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using Cloud Stack. They were using it to transcode video. And I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
Cloud Stack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think Cloud Stack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits with the Cloud Stack.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems, and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.